Welcome to EverestLabs' newest webinar, A Practical Guide to Data-Driven Recycling Operations. Before we get started, I wanted to do a quick overview of some housekeeping items. First, Apurva, if you could click. Yeah, we are recording this webinar, and everyone will receive a copy of the recording from me in an email in the upcoming few days. And then second, we'll be doing some Q&A at the end of the presentation. So if you have any questions that pop up during the webinar, feel free to place them into that Q&A chat at the bottom of the screen. So meet your presenters. Let's start with the main speaker today. We have Apurva, who is our head of product and marketing here at EverestLabs. And hello, I am McKenna. I am a marketing manager here, and I will just be moderating and supporting as needed. Agenda, we're going to start with a quick EverestLabs intro, move into value drivers for MRFs, talk about deploying AI in a MRF, and then go over 3 practical examples. And with that, I will pass it over to Apurva.
Thanks, McKenna. Just a quick note about EverestLabs. We're an AI company that's developing solutions to help MRF operators work more safely, get better performance out of their facilities, and automate their plants. We've been in the business since about 2018. We've got well over 100 systems, vision systems, and robotics out in the field, probably closer to 200 at this point. AI is behind pretty much everything that we build. So the AI drives our robotics business. It also drives our data and automation business, which is becoming a bigger and bigger portion of our business, which is what I'm going to be talking to you about today. We've had our models running since 2018. It's been trained on data from well over 1 billion objects, real world objects that we experience in the field. So the systems are fairly robust at this point. And we're using a lot of recycling plants throughout North America, and we've recently expanded outside of North America as well into Australia and Japan. There's a lot of sort of experience that has gone into building our data solution and our AI solution, which I'm excited to talk to you about today. I'll start with why build an AI for recycling operations. There's sort of like, we've surveyed a number of facilities and customers, and most of the value that they will derive from the AI integration into their plants fall into 4 buckets, right? MRFs are, essentially a processing plant. And so increasing throughput and utilization of their conveyors and their plant real estate is of primary importance. I mean, that's what they do. They receive materials, they process, and they ship materials. So increasing the throughput of that directly impacts revenue. The second big bucket is eliminating downtime and having to recirculate material because the first go around it wasn't done well. There were anomalies or failures in processes that caused a bad output. So needing to recirculate over weekends or off shifts. Also being able to eliminate downtime due to failures is another big reason. Improving the quality of the materials that they've recovered and the volume of materials that they've recovered, which directly translates into revenue. That's the third bucket. And fourth is just being able to do their business better, right? Being able to do it with data. So being able to audit material streams, track the plant performance, whether it's performance from shift to shift or day to day or month to month or between one plant to another. Some data to really drive sort of metrics that matter to them and drive it consistently. That's sort of the fourth bucket. And that's what we hope to address with our AI solutions. Just a quick note here on, how, to deploy AI, specifically vision AI into plants. We have a number of webinars that kind of talk just about this. So if you're interested in sort of the tactical aspect of deploying vision systems, please visit our resources section of our webpage. There's a lot of good material there on how vision systems are deployed. But I'll touch on it really quickly here. As I mentioned, the AI has gotten fairly robust, and it can be placed in various strategic locations in a plant. And what you really want to do is sample how the materials are flowing in and out of a plant. So some key locations would be kind of after your initial 2D, 3D separation. So you get a good idea of your 2D stream and your 3D stream. Then some other locations would be on your, before materials get baled at quality control stations. So before items, after the items are processed and before they go into the bunker to get baled. And then finally on last chance lines or residue lines where, the output of that is going straight to a landfill. So if you have those locations mapped, then you have a pretty good idea of how materials are flowing in and around the plant. And so you started building a picture of your operations. We also, in addition to deploying vision systems, you also need to deploy other infrastructure on a plant so you can actually take actions based on the data, right, that you're collecting. For us, we have a central compute server that sits somewhere in the facility, and it serves the purpose of collecting data from all the vision systems and running them through an AI model to extrapolate the results from that. Lots of other types of sensors can also kind of feed into this data stream. So we regularly collect material from data from things like encoders that are measuring belt speed and belt rotation. We collect data from environmental sensors. All of that is feeding into our central server. That's sort of the input of your system. And then the central server is doing all the heavy computation because essentially you want this data to be, created and acted upon at the facility. So you want real-time action. And so, you're doing it at the facility, so you have real-time data available for you, and that data can go into your control systems, equipment control, or a SCADA control if you have one, which can then feed into your operations, kind of your view that your operators have into the plant. That data can also go into sort of what I call the management view, which is providing a view of that data through the cloud into an analytics platform like the RecycleOS data platform that we provide that allows kind of supervisors and plant managers to view how the performance of the plant is. That same data can also make its way through a local network into a control center if you have one, right? So if you might want to know what exactly is happening in your plant at any given time, you might have some metrics that you want to share with your facilities operators, and we might want to know things like alerts and notifications, and so they can all happen through a local network. And so you need a fairly robust infrastructure in place to be able to not just look at the data but act upon it. And we typically look at integration of AI into sort of three different steps. So the initial, where most operators will start with, is integration at the line level. So this is choosing strategic locations within the plant to audit the material stream. Places like last chance lines are really good locations to get started. You have a full view on what your plant is losing and how much is going, what materials you're losing and what's going into your landfill. That gives you insights into what you might need to do, how you might need to act to improve your operations. You can also integrate vision systems and AI in the process, right? A process is any step where sortation happens. So it could be before and after a piece of equipment, or for example, before and after an optical, or it can be a before and after a series of equipment. So if you've got a series of opticals and eddy current systems that's separating different 3D material, that could be a process as well, right? If you've got robotics in your plant, it can go before and after robotics to know exactly what's happening in those steps. And there, once you have that, then you can start to optimize those steps, and you can start to automate those pieces of equipment. And once you've done enough line level integration and process level integration, you kind of have a digital twin or a full view of your plant. And so there you can really then start to turn the knobs that you need to get the output that you want. And that's some of the examples that I'll be sharing with you are along these types of integrations. So the three examples I'm going to share with you, one is dealing with contaminations on a UBC line. These are all real world examples, just kind of obfuscated the names of the clients. I'm kind of sharing with you sort of the end result of what we're able to achieve. The second is doing a mass balancing of a full plant to understand sort of root cause for contamination and also to look for opportunities to increase recovery. And then the third example I'll share with you is a belt utilization improvement project. And I'll be jumping back and forth between a PowerPoint and sort of the web dashboard. So if there are any glitches, I apologize in advance. I'll try to do my best job of steering back and forth between these. So let's jump into the first example. Um, The first example, as I mentioned, is a UBC line that is automated to ensure a very high quality standard. So what I'll do is I'll share with you some of the data behind, the data that we're capturing on this dashboard view, and then I'll share with you what we're actually doing to ensure that the quality standards are met, right? So this is the dashboard for the for that particular line. This is looking at data over the last 7 days. And this is sort of a standard format for looking at QC lines where there's a sorter. So you kind of have the initial belt composition. So there's a vision system before this line that's looking at what's coming into this line, right? So what this line is allowing aluminum and tin to pass by, and then everything else is being treated as contaminants. So the bunker purity going into this line is about 92%. This particular facility has a requirement to sort everything to 95% accuracy. So we're not quite there yet, right? It's 92%. It's good, but it's not where it needs to be. You can look at the same data in terms of daily composition, so how your material composition is changing by day, looking at different, kind of the contamination by its different output. Now, one of the things is you could recover some of these materials like HDB and PET and sell it. So it gives you some insights into what are the contaminants, which contaminants are essentially residue and which contaminants may be valuable. And the other thing it tells you is, how many contaminants are there per minute. Now, this is important because you might want to staff this line, or you might want to put a robotic sorter. So you kind of have to know, what is the contaminants per minute that you need to remove from this line, and we can break it down on a minute by minute basis. This particular line has a robot in it, pulling out the contaminants. And you can see the performance of the robot. It's in terms of pick efficacy, so successful picks, as well as pick rates, so how many picks it's doing every minute. And you're kind of looking at it from the last 15 days sort of view. But you can change all of that if you go up to your filters. You can change your filters in terms of exactly what time frame you want to look at. And so ultimately, this line at the end of the day, after the robotics remove the contaminants, it's above the level of purity, the 95% that you wanted to get. Now, that's great, right? There's still some contaminants available on this land to pick. It's not, 100% clean, but it's above the quality that you wanted to get. Now, that's not the full picture because this is a 97% over 15 days. Now, there are going to be hours and duration where there's going to be more contaminants going through than what the sorter or the robot can pick. And because every bale has to be over 95%, you've got to do something about that. So if you look at this view, which is your minute by minute view, what you're noticing is there's a lot of spike in terms of the materials that are coming into this line, right? So sometimes it goes up, sometimes it goes down, and times that it goes up, the sorter may not be able to keep up with it. So some of this material is going to flow through into the bale. That level is about 200 objects per minute. So you can see that there's quite a lot of moments in time where you've got more contaminants than you can deal with by having a single sorter or a single robot in there. So this is where sort of the action happens, right? This is sort of so what I just showed you is sort of insights, but really you want to take some action. So what we built for this customer is in a control system. What you're looking at here, I'll click on it, is a um, HMI panel view. So essentially, this line has a recirculation belt. So there's a belt that's moving for the quality control line. There's a vision system. This is the sorter I was talking to you about, and that belt moves forward, drops into another line, which goes into its bunker. Now, that's the forward motion when contamination level that's escaping the sorter is low. If it starts to exceed, there's a control system, fairly simplistic. It's an I/O controller with a Modbus output that essentially ties into the belt drive and reverses the direction to recirculate the material when the contamination levels are too high. So there's sort of a two-step process that this customer is using to really get to that, ensure that 95% purity. First is putting a robotic sorter there, and then second is using the data to recirculate the material when the contaminations levels are too high. So essentially, you're eliminating all bale rejection, right? You're guaranteeing the performance of that bale for every bale at any given time of operation. That's my first example. My second example is using what we call mass balancing to examine cross-contamination so you can optimize your plant, right? So what mass balancing is you place, as I mentioned before a couple of slides ago, placing vision systems strategically at the input and output locations. So you can analyze the inbound stream and the outbound stream. So in this picture here, in this case, inbound stream, these are all the inbound material, valuable material that the MRF is interested in. This is sort of the inbound stream of that. This is you can plot this in terms of the number of objects or in terms of the weight of the objects. And what you're looking at is where do these objects end up as they flow through the facility. And what you're seeing here is the outbound stream. So on the outbound stream, if I look at the quality control lines, which is essentially the pathway into baling these commodities, you can start to see that there's some issues in this plant, right? For example, the main issue that you can see is there's the PET stream, which is going, the PET QC station, which is going into the PET bunker, has a lot of fiber and paper mixed into it. It's quite a bit. And it's way more than what's acceptable. And so you start to dig deeper into why that's happening. And so the data tells you something is happening, and it points you towards sort of the culprit of this symptom, and it's essentially pointing at an optical upstream of this system. This optical is a dual eject optical. They've got mixed materials coming in after it's gone through kind of a OCC screen, and PET is ejected upwards, fiber is ejected downwards, and mixed plastics, different plastics and residue continue on, and they go through a series of other opticals. But here, plotting this what we call a Sankey diagram, this inbound and outbound, and kind of isolating it to different days and different conditions. What we notice is that during wet conditions, you see something like this, where you get a lot of fiber into this optical. And I think there's a logical explanation of that. There's when fiber is wet, it's heavier. One is it's harder to shoot on that fiber. The second is the material being wet gives you poor readings, infrared reflections. So you're not really the detection of fiber is poor. And so there's a few things you can do. There are recipes you can change on this optical. So you can increase the air jet duration and slow down the belt. So increasing the air jet duration, make sure the heavy objects can be, the heavy fiber objects go to where it's supposed to go. And then slowing down the belt gives it a little bit more time to read the inbound belt to the optical gives the NIR a little bit more time, a little bit more signal versus noise to be able to determine it's the right it's fiber. And so doing those two changes really helps eliminate the contamination. And so, this is sort of dynamically being adjusted based on the what the vision system is seeing. And essentially, this eliminates the need for any manual sorting at the PET/QC station. Now, we know right now the commodity prices for PET are pretty low. It doesn't quite justify having a sorter in a station to clean up the PET stream. So, doing an adjustment like this essentially allows them to put one less person on the QC station. Um, that's one output that's practical. But if you look at these mass balancing charts, it gives you there's so much rich data in there. There's experiments within experiments happening at your facility every second of your day, and you can kind of go back and ask it questions and understand what's happening in your plant that maybe you hadn't thought about the first day that you built this plant. For example, you can go in here and you can say, hey, if let's say an EPR regulation comes down the stream and that you need to start then collecting something like a Tetra Pak and clamshell because that's required of you. Maybe you weren't doing that before, and maybe you weren't looking at that data, but I can select those objects as simply as that. I can run that data and I can see now, hey, my Tetra Paks, where is it actually coming in and where is it ending up? So my Tetra Pak, which is essentially your aseptics, are ending up in your aluminum QC and your PET QC. So you can kind of go back upstream and say, where do I need to put, either robotics or some kind of a sorting step to be able to capture these. Same thing with clamshells. Where are the clamshells going? Right now, they're all going into the PET bunker. And so, you might want to do something about that to remove clamshells separately, a little bit upstream of the PET sort of QC station. So it gives you insights into things that you may not have initially thought about, but are issues that you're dealing with going forward. The third example I'll give you is nothing to do with sort of individual commodities and materials, but essentially sort of belt utilization, which I think is a huge opportunity for recovery facilities. So similar to my previous example, we've got a last chance line, and we're looking at some data on that last chance line. And this particular facility has set up some KPIs, key performance indicators, and one of the KPIs is around the belt utilization. So you can see, okay, how much of that belt is being utilized at any given shift. And that tells me, okay, how much maybe opportunity there is to add more material or maybe even just kind of balance the material out so that you get better, processing of that material. So you're kind of looking at this and saying, okay, like utilization is pretty good. The belt is being utilized 90%, roughly 90% of the time. I can dig deeper and I can go into that. And so what I'm looking at here is sort of your material processing information. So your blue line is your whether your belt is running or not, and your green line is how much material is on that belt while the material's on. So in the high state, it's in during these times the belt is running, and during these times the belt are off. And you can start to see that, hey, like the amount of material that's on this belt is very, very uneven. It spikes a lot and goes down a lot, right? So even though I may be processing material, there's probably a lot of room for improvement to spread out the material on this line so that the processing steps actually work better. Like, any processing equipment works better when there's a steady stream of material, not when it goes up and then goes down to nothing. I mean, your sortation, your rates, your recovery rates, your purity rates all depend on sort of steady input of material into that piece of equipment. And so you can start to dig into that here. You can say during in this particular instance here, that's about a 2-hour period. Um, you're only running material for about an hour. There's a little bit over an hour where you're actually not running very much material at all, right? So that gives you some insights into the fact that you could improve the flow of materials into your belt. You can take that a little bit further and you can do, belt loading analysis, right? So this is a belt loading analysis. For a belt, that's, belt one is the source belt, and two and three, it splits into two streams. So belt two and three are your destination belts. And you can start to kind of develop parameters around your belt utilization. So I've got about 23% idle capacity on that belt. You can do a couple of things with that. You can, like I said, you can smooth out the material. Try to smooth out the material if you have a capacity, ability to meter the amount of materials you put onto the belt. You can also think about increasing your throughput, right? There might be commercial business that you can get to fill the excess capacity that you already have in this belt. And just by looking at the belt, you're not going to be able to understand exactly how much your capacity is, right? The other things you can start to do is you can start to look at flow rates. So flow rates is essentially your volume, how much volume you're processing and how fast the material is running. So it's measured in cubic feet per minute. Flow rates is has to either when you go from one belt to another, flow rates has to either be it has to match. So your input flow rate has to match your output flow rates. Otherwise, you start to get accumulation downstream, right? So if I have vision systems looking at that, I can start to determine accumulation risks downstream from that belt. So I can start to say, hey, my volumes are going up on this belt. You might want to think about speeding up the follow-on belt, or looking for accumulations, which essentially leads up to jams, which leads to shutting everything down, and then leads to downtime, right? You can also look at um, you know fill percentages. So you can say, hey, this belt has a certain amount of utilization, and the fill percentage, it tells you how much more from a surface area standpoint you can fill onto that belt. So you can really get a sense of what your capacity of your belt is, what the excess capacity might be, and also what your risks are in terms of accumulations and jams, which all lead to downtime in a facility. So those are three examples. I think they highlight, some very practical things that commercial operators can be doing with Vision AI. I think, my point with kind of showing these examples is, data is really nice to have. Data through dashboards is really nice to have. It gives you great insights, but taking action on that data is even better, right? So always ask yourself, what can you do with the data to make my operations better? Because the actions come for free, right? So you've already paid for the system where you're collecting data. Now taking actions from that just come for free. I would say the vision, AI capability combined with automation, combined with agentic AI, which is a new capability we're adding into our solution, really gives both higher efficacy as well as higher efficiency. So efficacy is how much you can achieve, and efficiency is how much resources you need to put into achieving that result. Using AI, you can really drive higher efficacy as well as higher efficiency. So efficacy gives you more revenue, efficiency lowers your cost. Um, and paybacks for facilities that do full deployments with AI integrated into their full plants can save hundreds of thousands to millions per year based on some of the results that we're seeing. And there's a lot of new exciting features that we're building using AI. And so stay tuned to this space. We'll have a lot more materials coming that we'll share on use cases, case studies, customer testimonials on using AI. So I'll close with that, and I think we'll open it up for questions.
Awesome. Thank you so much, Purba. We do have questions that were coming in during the presentation, so I will just start asking those. The first one is, how good are our vision systems at estimating massive materials? Is this done on conveyor or yeah, is it done on conveyor or versus on a tipping floor? Um, yeah.
Yeah, good question. So, mass estimation is a difficult problem to solve because you're going from measuring volume to estimating its mass. For certain material types, it's very good, well over 95%. For example, aluminum cans, like it's almost perfect, right? Because all cans are kind of the same weight. For other commodities like paper and cardboard, it's much more difficult because it's influenced by thickness, it's influenced by whether it's wet or not. So it varies. So what we do is we have sort of two ways to handling mass estimates. So the default way is kind of a correlation we've done on, kind of past where we've measured, mass of a lot of objects and converted into, what an average mass is for a particular commodity type, right? And that's pretty good. Like, all of the commodities that would be well over 80% if you do something like that. If you want to get really accurate, then we trigger a calibration study where we will do a calibration study in your facility where we'll run samples under your belt and we'll collect data on the the volume of the object, and we have algorithms that we run against the weight of that object to come up with exact algorithms. And when you do that, you get much more precise measurements, and we'll also get precise measurements on exactly the things that you're interested in. Because when we in different recyclers, different facilities, different regions are interested in different objects, they also group things differently. And so when we do a kind of a custom calibration to your site, then it becomes calibrated exactly to how you define your material and what you're interested in looking at.
Awesome. The next question is on the UBC dashboard, what are the units used? Is it number of items or something else? And then the purity level was characterized as 92%, but what is that percentage of?
Yeah, so those dashboards are completely custom, so you can count the amount of objects in terms of the number of pieces. You can count it in terms of weight. You can count it in terms of volume. In that particular one, I believe it's based on the number of pieces. Um, and I forget the second part of that question, McKenna.
Yes, it is. The purity level was characterized as 92%, but what is that percentage of?
Yeah, so for that particular dashboard, it was based on the number of units, but you can easily do the same thing for in terms of the other measures as well.
Alrighty. The next question I can answer, it asks how many classes of materials can you identify? We right now can identify 60 plus classes of materials from plastics to metals to fibers, wood, contaminants, and we can train on a new material type in about 2 weeks. For Apoorva, next question. What is the relationship between throughput and quality? If I want quality at 90% or 95% or 98%.
Yeah, so I think it's more to do with the consistency of the throughput than sort of an overall throughput at the end of the day in terms of quality. And it's different for different pieces of material, different equipment, right? For example, optical sorters need very singulated material, and it can handle very high speeds, right? So that, if you need a singulated material and you know the speed, you know exactly the flow rate at which materials need to arrive at an optical sorter. Same is not true for something like, like an eddy current separator or a magnet, for example. I mean, there's some dependency on that, but not as much, right? So it all depends on what equipment you're looking at. But what you want to do is you want to have consistent throughput instead of kind of saying, hey, I need my throughput to be X percentage. And it's kind of dependent on the width of the belt, the volume that the belt can handle as well. So there's a few factors there, but what I'd look at is making the throughput more consistent versus increasing it or decreasing it. Once you make it consistent, then you know how much more room you have to add more materials to that, right?
Perfect. Next question is, has EverestLabs applied, or actually we'll do this one. How many MRFs have integrated this technology, and does your company aggregate and or share data from the MRFs you work with?
Yeah, good question. So as I said, we've got probably close to 200 vision systems and robotic systems out there. We don't, um, we in terms of the data sharing. So what we do is when we collect data to train the model, it's a completely anonymized data and it's not even recognizable data. For example, it's not images and pictures. It's, basically the weights of the model. So these are just numbers that go into a matrix. So there's really no identifiable information about anybody that's going into the model. Then there's dashboards and analytics that we create that the customers have access to, and that's completely the customer's domain. So if any dashboards that we set up, our engineers and our operations team will have access to it so that they can set it up for you. But outside of that, no one else has access to that information.
Perfect. The next question is, has EverestLabs applied these methods to C&D materials, or has the focus primarily been on MRFs? If the latter, does EverestLabs plan to expand to C&D?
Yeah, so we do have some plans. We are kicking off some what we call POCs, proof of concepts, into C&D facilities. We haven't focused on C&D up until very recently, primarily because the types of you know um, facilities, they vary quite a bit in terms of how facility is laid out, vary quite a bit between C&D and single stream MRFs, right? Single stream MRFs are fairly repeatable. The design of one single stream MRF is roughly more or less similar to the next. They might lay out things differently, but the types of equipment that you'll see and the kinds of belts and the volumes and the materials you see are fairly similar. When you go into C&D, that's not the case anymore. Every deployment becomes sort of bespoke. And so we haven't, for that reason, focused on C&D, but we are starting to do some robotics deployment in C&D facilities where we're recovering sort of smaller fraction materials. So if you're interested, happy to chat about that. I personally, want to learn more about applications in the C&D space. So yeah, please reach out. My email address is on the slide here. If you got a C&D application.
Sweet. I can take this next one. What is the deployment timeline for a vision system? So deployment of a vision system usually takes less than a day, and it's done already during planned plant downtime. So during off shifts, evenings, or any time when the plant isn't running. So even on weekends, and this is the same for our robotic deployments, which we usually do on weekends as well. Alrighty. Does your AI-supported approach work also for material categories that are typically hard to detect and handle, like organics or food waste? And what are the practical limitations for such categories?
Yeah, it's a good question. Again, another application where we haven't put a lot of energy into organics and waste. The major limitations would really be, in especially in organic waste facilities, is the burden. So we utilize vision, which is essentially kind of depth sensing cameras, and it can only see what it can see. So it can only see the surface of the material. Now we've got techniques where if objects overlap with each other, we've got techniques to sort of try to understand what objects, the underneath layer, what those objects are. Even if we see like 25-30% of the material, our models do a fairly good job of picking that up. But if it's completely covered by something else, then it's really, really difficult, right? So estimating, the size, weight, volume in those situations are difficult. Now, in terms of, can we estimate, can we identify contaminants in those streams? I think those are much more doable than the main primary categories in those streams.
Nice. So with the data from the systems we have operating, wait, hold on, let me rephrase this. Can you assist someone in designing a facility using the data we have from the systems we have operating?
That's a great question. We are not MRF builders and system integrators. We come in after the fact, when MRFs have already been in operation and there are questions around, improvements and so we get involved at that stage. I would say, like we are not experts in building MRFs and exactly, kind of helping figure out, the the sort of that integration process. But we can certainly be involved early on to tell you, okay, based on the design, um, objectives and criteria that you've set out for yourself, where would you monitor and what would you monitor and how would you look at that data and how would you want to consume and apply that data? Especially if you're doing a MRF design early on, you have the opportunity to integrate the data into your control systems, right? And that's, I think if you're in that stage, you should definitely take advantage of that because that technology exists today. So while you're building it, kind of, building closed loop feedback systems, building automation systems are much easier done when you've initially designed them earth than when you've already actually designed and you're trying to make it do something else. So I would say we can certainly get involved in the early stages, but we wouldn't be the ones to kind of advise you on how to build your plant.
All right, this is the final question we have. So if anyone else has any questions, feel free to pop those in the Q&A box while we answer this last one. So the question is, can the belt loading data be integrated with the PLC to slow down or speed up the belt to maintain a better flow? I think this is from the aluminum example.
Yeah, absolutely. There's many ways to do that. Because there's um, we collect data. So we're collecting data on an object by object by the vision system, and then we're analyzing that data and outputting some metric, right? And that metric can be, purity rates, contamination rates, burden of depth, volumetric rates, flow rates, what have you. We can convert those data into those metrics. Then those metrics, how that gets integrated into a PLC or control system, there's many ways to handle that. So the easiest way would be, we can put that data into an I/O controller, and have some logic built in where it changes the output of that I/O controller, right? So the output can be kind of an analog output or some kind of a digital output, and that then can kind of could either integrate directly into the equipment or can make its way into a kind of an automation system like a SCADA system, and then you can program control logic based on that. So there's lots of ways to do it. I think, automation systems are always bespoke. Everybody has, every company probably has a different integrator and a different set of technologies that they use to build automation systems, and there's many ways to integrate to them. So yeah, the short answer is yes. The long answer is, I think, you have to kind of work with the engineer who's designed that system to know what's the best way to get that data in.
Awesome. We have another question that came in. It asks, what differentiates EverestLabs from other AI robotic MRF servicing business competitors?
It's a good question. I think it depends on which. I'll focus on the AI side of things, versus the robotics because this webinar is more on the AI solutions. I think what really differentiates us is the operational aspects of the AI, right? So I think most of the companies that provide AI provide you with the data. And what we provide you is with real-time data that has actionable outputs. And so, because of our experience in building robotic systems, we've gotten pretty good at knowing, sort of, how to integrate data into MRF systems. And so, that's an area where, we believe, we have a leg up and also believe that, that's what drives value. And so it's an important distinct differentiation for us. There's a lot of technical, sort of details that I didn't get into about, exactly how our AI works. One of the things that our AI, infrastructure is good at is extremely sort of, adaptive. So, for example, one belt never looks like another belt, or one facility never looks like another facility when it comes to the things that the AI model is looking at. Our models understand the context and the differences between different systems, and can adapt very, very fine rapidly. We call this fine tuning. So once our vision systems go on to a line, it'll understand the differences between this line and all the other lines it's been trained on, and it'll fine tune itself to make accurate predictions on that line. And it does it very rapidly, right? And so, a lot of times, the it's, and this is not a model thing, it's more of an AI infrastructure thing. And so we've got a lot of kind of infrastructure built in that is always analyzing the performance of the AI and fine-tuning it based on what it's seeing. So and also the other thing is our AI is super, super fast. So we're making predictions on hundreds of objects within, like, 10 to 20 milliseconds. And so, when you need to do that in order to be able to take real-time decisions and real-time actions. So that's another sort of technical differentiation. So, there's a lot of things that, we've kind of developed into our AI, having been in the MRF business for the past 6 years. And so I feel like, we're at a point where the AI is pretty good, and we're at a point where kind of the we can talk about the art of possible, but I think we kind of actually already doing a lot of the things that we believe was possible with AI.
Awesome. We have one more question. It is similar to the ones we've had in the past, but a little phrased a little different. So, does EverestLabs have the ability to see data from all the MRFs it works with and analyze the different material compositions that they manage? So, for example, are you able to say something like in 2025, our technology has helped manage X tons of plastic?
Sure, I think we have that information. I think in terms of, disclosing that information, because it's, a lot of that data is customer data. I'm not sure that we do that.
All right. I think that is a good question to end on. Nothing else has come in. So, wanted to say thank you to everyone for joining us today. As a reminder, just keep an eye out for an email from me that has a link to the recording of this webinar. If you have any additional questions or want to get in touch with us, you can email myself or Apoorva. His email is on the screen here. And you're welcome to ask us any follow-up questions that might pop up after the webinar. So thanks again and have a great rest of your Thursday.